specifying the optimal powertrain for large and hyperscale data centers. I think that as everybody is working from home more, I'm sure you might have had the embarrassing experience of talking away and realizing that you were on mute. Well, that just happened to your host here, Greg Jones. So I apologize for that, but hope that you guys were able to stick with me. So thank you for that. So the topic of our Digital International Co-location Club this quarter is around the optimal powertrain for large and hyperscale data centers. As we get into this topic, I think it would be odd not to at least acknowledge the challenging times that we are in, and also acknowledge the work that the industry is doing in order to keep the existing data center infrastructure up and running. This is obviously critical to our fight against this pandemic, and will be more critical as we move forward as our habits change as far as working and working remotely. And we really believe that this topic will become even more relevant moving forward. So we're going to start with a quick introduction and then talk about design optimization. So really talk about the design of the data center and how we believe that can be optimized, and then move into the build and delivery. So this is not just a hypothetical exercise, but something that we can go deploy on an ongoing basis to increase speed to market and lower overall total cost of operation. And then we'll finish with some summary and some question and answer. So, what I would like to do next is to introduce my colleagues and presenters. Brice Martineau-Lagarde is a global solution architect with the Cloud and Service Provider segment. Long history in the segment, working with clients throughout the world and throughout the industry. And he is joined by Joe Kramer. Joe is the Sales and Marketing Director for our Modular Data Center division. So thanks to Joe and thanks to Brice. And with that, I will hand it off to Brice to talk about the design of data centers.
Thank you, Greg. Can you hear me well?
Yes, I can hear you well. I see you found your mute button.
Okay.
Well done by you.
Very good. So hello, everyone. Thank you for joining. I would like to start by quickly introduce some key values that manage the business we are talking about. As a generic topic, we know all about that. What I would like to highlight is the fact that the market has really improved all those parameters, all those KPIs. And we are getting to a much more mature situation because all of them have been drastically improved over the last decades. So the technical challenges remain more or less the same, but we think that we can take that in a different manner, and I will explain a little bit why, especially around the standardization. So standardization is we think a good way to move forward for two reasons. The first is it's a way to continue to make some savings. And the second is also about more collaboration between Schneider, our customers, but also the ecosystem, so system integrator and C&E's company. So, as introduced by Greg, we have two topics, two ways to standardize. The third thing is much about the technical aspects. So I will highlight the optimization from technical aspects. I will speak about the dynamic views, which means that doing integration is also considering not only the design as such, but also the way that the design will behave, and especially with the sequence of operation that can occur during the life cycle of the system, as well as doing a real protection and control, validation and test upfront to the manufacturing and to the deployment. The last thing is about connectivity. I will share with you a couple of things related to the chance we have to make a lot of connections to the product to be able to have afterwards optimization during operation, sorry. The second aspect is the delivery. So standardization is not only about the design, it's also about the delivery model. And Joe will speak about that to develop the assets and the capabilities we have to standardize the delivery model. So let's start by the design optimization. Since we have made a design with bigger players, and whatever the size of the data center, we realized that for 10 megawatts or for 20 megawatts or 5 or even 100 megawatts, there is almost the same type of powertrain, and this powertrain can be repeatable or repeatedly produced. And that's a big chance we have if we consider this for the standardization. The medium voltage can be less standardized, but definitely this is interesting. The powertrain, the low voltage powertrain, is very interesting to consider due to the volume and due to the fact that whatever the scale, we will have more or less the same size. And that will really help to deliver a better cost, quality, and efficiency and footprint of the whole system. So this type of thing is applicable whatever the type of data center in terms of sizing, but also in terms of life cycle. So that can be for new construction or for existing building. That can be done on skid, or that can be a prefab enclosure that is going to be built outside of the existing building. So if we break down the different components, those components on the top are, so you can see on the top the powertrain of the powertrain, the medium voltage switchgear. Then we have the transformer, and we have a distribution of the electrical power through UPS and to let's say the feeders downstream. And in this topology, I take this example. It's a very simple one. It's as an assessment for this one, the backup generation is considered at medium voltage. This one considers also a two-end distribution on the low voltage powertrain, and there is no cooling distribution. So I took this example, but of course we have the flexibility to add cooling to change completely the low voltage distribution topology by N+1 or N+2, having a swing bus with some transfer switch to be able to reduce or to change the type of distribution we would like to achieve. So on the right side, the integration will also take into account, thanks to the EcoStruxure suite, from monitoring to SCADA system, and also develop capabilities for advisor layers, so meaning developing analytics and more advanced application on top of the standard operation system. So I'm going to break down a little bit the integration aspect. The first thing we are thinking about is the size. So we want to meet roughly the size which are used today in the colocation market. Of course, we can do an equivalent type of things for telco. For instance, with the transformation to the 5G, that could be also a good exercise to make, but that's completely a different type of sizing. So I will concentrate with the size of the collocation and the needs of the collocation, which are 1500, 2500, and 4000 kVA for those examples. And on the left side, you can see that the first thing we are considering is the breaker, the medium voltage breaker. So with the 6 MVA and 11 kV, with 11 kV, sorry, with 600 amps, we can reach about 6 MVA. So using this type of gas-free breaker is very interesting due to the fact that as a minimum for 1500, we will have about 30% of power capacity use for this breaker. So the second aspect in terms of optimization we are considering is the transformer. We would like to be close to what the utilities are using, asking for. So starting from 1 MVA up to 3.5 MVA. Why? It's just because the volume and also the time to market. Having this type of size is very relevant to optimize the speed to market. The second aspect of the optimization is about the low voltage. It's a combination of the low voltage switchboard with the low voltage breakers. As you can notice, the first and the second MTZ we are using from 슈나이더 portfolio is a single pole. So meaning that in terms of enclosure, we will have also single pole, single bus bar, and the MTZ3 that we have to use for the 4000 amps is a dual pole and a dual bus bar in the enclosure. So there is a big chance that for at least the main breaker, the incomer breaker that protects the overall switchboard, we think that this breaker is the most not necessarily the most cost-effective, and in terms of footprint is not necessarily the smallest, even if the power that we can use is higher. So the last thing we have optimized is also the type of UPS to bring. So the sweet spot is about 1,1250 kW, and we can parallelize also those UPS according to the total power which is needed, especially for the 4000. But at least for the 1500, we can use the 1250, for instance, or even the 1500 with an N+1 module inside to allow an additional redundancy of the system. If we speak about the integration between those different components, the idea here is really to do the mechanical integration, of course. So it's first the mechanical integration and the cabling integration between the switchboard and the UPS from the main switch, the main circuit breaker, but also to the distribution. So that can be done also for integration of busways downstream to be able to have the preliminary integration before shipment. So the second aspect of the integration is really to have a protection coordination according to the different mode of the UPS. So the Galaxy VX has the chance to we have developed a patent for having an egg conversion, what we call the ink conversion, which is class 1 certified, and that can bring up to 99% of efficiency as a UPS. And we have also, aside to that, the traditional double conversion and the eco mode. And according to those different modes of operation, we need to have a continuity of the protection coordination of the whole system. So when we speak about protection coordination, it's really about having this secure end-to-end coordination between the medium voltage and transformer down to the distribution to the rack inside the IT room. We have also integration, means optimization of the ratings. So the short circuit current on the downstream is very critical, and it's a lot of small breakers that need to be integrated into close to the rack to protect the racks. And we have to consider this short circuit current end to end. And for instance, we also optimized the short circuit impedance of the transformer in order with additional 1 or 2%, in order to have the right form factor and the right size and range of small breaker downstream to be able to have the right cost optimization at the end of the day, not compromising, of course, the continuity of service and the protection coordination. So all this is an integration as we speak. It's not only the mechanical, as I said, but also the system when it works, managing also the different sequence of operation and the different mode of the different subsystems. So an additional point I would like to highlight is all those products have an intelligent device or communication device that are able to retrieve all the different sensor information or different controllers information up to what is called the power monitoring and control system. And this is another level of integration. The second part of the integration is thanks to the EcoStructure power monitoring expert, which is able, of course, to integrate a database, actually a SQL for that case, to make a data historian and manage the information and store it. It's also a capability to integrate the building management system or engineering tool, or, of course, third-party information. And the other part of the integration is to have a supervision dashboard. In that case, we have the capacity to integrate into the Wonderware HMI, the power monitoring expert interface, to be able to show different type of KPIs or much more supervising, let's say, the system or multiple powertrain or the end-to-end electrical distribution, and retrieve all this information from the different power monitoring system that are under this layer. Once it is done, then we have the capacity during the life cycle of the system and during the different operation mode to manage the safety, to manage the reliability of the system, and which is key for the SLA, of course, as well as the efficiency and the compliance aspect. So the compliancy aspect is about cybersecurity, of course. It's about local regulation. And combining the compliancy evolution also during the life cycle with the efficiency, we have really the capability to manage the sustainability of the system. So as we speak now, with the different parameters considered and integrated all together, this system is what we call the EcoStructure Power Ready. So that means that we can consider the top layer, which is on the top of the screen you can see here, to introduce more advanced layer or application, let's say, much more application, that can be combined with different other bricks of the system. So that can be, for instance, application related to how to source the energy, combining the information that what is really used, what is the demand versus how to buy the energy for the next couple of weeks or months. That can be a use case that also manage peak shavings, or also developing analytics that is able to optimize the maintenance program and the maintenance plan of the system in order to make cost optimization at the end of the day without compromising the performance of the system, especially the continuity of service. We can also have some more advanced AI bricks, such as developing digital twins and augmented reality to support the different mode of operation, have digital information when operators are managing crisis or are managing recovery of a difficult situation. So from the technical aspect, I think I have summarized most of the things that need to be considered. I will hand over to Joe now to introduce the optimization of the build and delivery.
Thanks, Brice. Hi, everyone. This is Joe Kramer. As Brice mentioned, I'm going to talk about what we're calling here build and delivery optimization, but really zooming in on prefabrication of these systems to be built offsite in a factory. So in my talk here, I'll talk a lot about prefabricated data centers, or also referred to as modular data centers in the marketplace, and give you guys some background on how that can be done and what's going on in the world related to this. First thing I wanted to introduce is just a little bit of history about this build approach. As I said, basically we're talking about building a part of a data center, or possibly an entire data center in a factory, and then deploying it on site as a large block. This has been going on in the market probably for about 10 or 12 years, and it's been through an evolution of a bunch of different phases. But in the last 2 or 3 years, as you can see by some of these charts, it's really become something that's a lot more common and has become a very accepted approach in the marketplace, especially in the hyperscale data centers. You can see on the chart on the left, this is some data that we got recently from a market study that I was kind of shocked about, actually, where they told us that the year-over-year growth in deployments of enclosed prefabricated solutions grew 65% in 1 year. And the feedback we got from that market study was that, yeah, that was just being driven by primarily by deployments in hyperscale data centers, either from co-location providers who are deploying prefabricated power solutions, or from the big internet companies who are doing that, as well as many other types of deployments using prefabrication. So the short of the story is that this is something that has really, in the last 2 to 3 years, become a very common part of the landscape in hyperscale and co-location, and certainly will continue to be. To give you a quick introduction of the different types of solutions that exist in the marketplace, I'm going to, after this slide, zoom in on the application on the left, the hyperscale data center, but wanted to introduce the different approaches that are out there. So for a hyperscale data center, we're typically talking about a prefabricated power solution, where a large data center will be built in a building, where the white space will be built in the building, and then the power and possibly the mechanical systems may be built offsite and then deployed as large systems in one piece. And I'll talk a little bit about the reasons why in the next couple of slides. The application in the center, a regional data center, is a situation where, say, a co-location provider is leaving its home market, or they have a very specific niche opportunity where they need to build a data center that is, I'll call medium size, but let's say it's a megawatt or something like that in terms of scale, where they may consider for a variety of reasons just doing that entire data center in prefabricated modules. And then the one on the right, a local edge data center. So that's maybe the traditional view of what prefabricated data centers are. It's a small requirement, maybe 100 kilowatts or less, a handful of racks that's going to a remote location, or as we say, the edge these days, where you have that kind of requirement. All of these could be present in a co-location context, but as you move from left to right, you're introducing other applications where you have other types of customers. But all of these could potentially be used by a co-location provider. Okay, so now I'm going to zoom in a little bit. This is a repeat of a slide Bree showed on the power solutions. So really in the landscape today, there are two primary types of solutions. A prefabricated power skid, which is what we have on the left. So that's and I'll show some pictures in future slides. That's basically a electrical system. Can be done with either low voltage or medium voltage equipment. A lot of my examples will be in low voltage, but that's your electrical system that's in your data center that's built on what we call a skid, which is basically an open platform where things like UPS, switchgear, transformers, etc., are built as a system in the factory and delivered to the site. Typically, that's going to go inside of an existing building and then be attached to the infrastructure that's there. The other example is a prefabricated power enclosure, where it's actually an enclosed solution where it's going to live outdoors. It's going to be adjacent to a data center and be delivered that way. So what are the values of doing this? Why are folks doing this, or why are we seeing this acceleration in the market? It really boils down to the three categories that you see on this slide: speed, predictability, and cost. Especially these days, as acceleration of building more data centers has picked up, everyone is trying to deploy these as fast as possible in most cases, and this is really where prefabrication can help a builder and a user build their data center faster. The values really come from the standpoint of taking a major system, a major part of your data center build out of the serial process that you need to execute on site during a build. So basically, we're taking the build of the electrical system that you would normally do on site out of the serial nature of your data center build. So we're building that system in parallel to the other activities that are happening on the data center at the data center. So that allows you to have a compressed schedule for the entire build because the electrical system is being built off site. It also, because we're doing more of the testing and reliability checks in the factory, your time on site when it shows up should be reduced as well. The predictability, and it's interesting, all these three things actually contribute to each other. So it's not like they're standalone. The speed and the predictability and the cost all contribute to each other and sort of multiply upon each other. But the predictability really is driven from the fact that when we start the project, we're going to have the design. Obviously, in a factory, we cannot build a system without it being completely and fully engineered down to the detailed level. So we're pulling some of those things that might happen in a more fluid construction environment and putting it in a factory environment. So the engineering up front will be a little more stringent, and then, because it's being done in a factory, there'll be more control over the build. There'll be more testing that occurs in the factory. It might be the same testing that occurs on site, but we're doing it in the factory and removing that from what's happening on site. So when it turns up, it's going to be more reliable and be able to be turned on faster. There's also a dynamic around this where moving to, and it is kind of a customer-driven decision, but moving to a prefabricated module kind of drives the mindset of the user that I really need to standardize. So, because I want to deploy these almost like a cookie cutter, right, and move them around. So that dynamic of using prefabricated module also drives that standardization, which ultimately drives increased predictability. And then finally, cost, right? So there's a couple dynamics to cost. When we talk about outdoor prefabricated modules, there's an interesting dynamic where you are actually deploying part of your building with the electrical system. So there's a dynamic where you can actually save costs on your overall building by using prefabricated modules. I'll talk about that a little bit on the next slide. But really the big driver from cost tends to be around delaying your investment, right? I don't deploy these systems until I need them, until my end user that's using the data center needs the capacity, and then we deploy it just in time. And that way you can save the investment on that system and deploy it as you need to go. There's also some other dynamics, especially in very crowded and popular data center markets where there's a lot of building. You can have constraints on construction labor. You can have constraints on electrical contractors. When we move that to another location, to another market, there's more control over those labor costs. And again, the predictability that we get should reduce things like change orders and longer project. If your project's shorter, your investment on your project resources on the site should be less.
Hey, Joe, Greg here. Can I jump in with it? We had a question on the chat that I think everybody might be able to benefit from. So they talk about placing prefab inside an existing building where, stop me if this has ever happened to you, with limited access, smaller doors, elevators, access hallways, et cetera, kind of real world type of stuff. So how do we handle those sorts of issues?
So placing them inside, it's an interesting question and maybe a leading question. I would say, generally speaking, the marketplace is moving more towards the outdoor modules. And part of the reason are those challenges. Obviously, if you're talking about something that's 30, 40 feet long and 10 feet wide, there has to be a plan for that, right? If you're talking about an existing building that doesn't have a path for that, then power skids may not be a solution for that site. That's just a reality. There's not another way to answer that. What we see with customers who do use power skids is generally they're applying it to a site where they at least planned for that in advance.
Great, thanks.
Okay. So I wanted to talk a little bit about the advantages of a power module deployment. I hit upon this on the previous slide. But basically, a power module, what I call a power module or an outdoor enclosed power module, is a box that looks sort of like a shipping container, although I'll stress that it is not a shipping container. It'll be something that is right-sized for your system. And the typical application is, okay, I'm going to build a white space in a building a traditional way, the way those buildings are built. And adjacent to that, where I have things like my generators and my transformers, I'm going to put down a power module that is my electrical system. So we're probably all familiar with how you can scale out things like transformers and generators as your capacity grows in these buildings. So it's basically taking the same approach to the rest of the electrical system. So your low voltage system, your UPSs, et cetera. So some interesting benefits about that is when you're chartering a new site, some of the benefits you can get is I can build that building initially smaller. So it's a little bit of a smaller footprint. Some of the investments that you put into the building, like cooling, like fire life safety, and things like that can be reduced. And then as you deploy your data center and you deploy the electrical systems, you deploy the building itself, the electrical system, the fire life safety, and cooling along with it. So that's really what we see as a big trend in the marketplace, is this kind of approach. Just some dynamics of the market is it seems like folks want to be able to deploy at the largest building block possible. So something like 1.5 to 2 megawatts in a single container. Basically, the message is, how big of a system can I put in a single container, and then deploy that. So we see a lot of examples of clients doing like a 5 to make 4 system with a 1.5 megawatt block to build out in, what does that come out to, 6 megawatt chunks as they turn on more capacity in these data centers. So this is just to give you a visual of a design of what it looks like. This is a 2 megawatt power enclosure. What's inside here, in this case, this is a low voltage solution. You can see we have input switchgear on the left, output switchgear on the right. Part of our battery system is here in the middle. Go on to the next slide. This is kind of the other side of the enclosure, if you will. We can see there's a UPS, some more batteries. In this particular design, we have a cooling system that kind of hangs off the outside of it. And then you can see over in the corner, there's some support equipment and a fire system. So those are the main things that are inside of these. Is the typical thing when we talk about a low voltage system that is in a power skid as well, in a prefabricated solution. And it's the same things that you're going to have in a regular data center. It's really just a matter of packaging them. Okay. So I'm going to move on to just a quick discussion about power skids. I'll try to maybe touch on Greg's question again. So a power skid is a little different than a power module in that you can see the picture. You can see the platform of basically the extra things you're adding to this is quite minimal. You're adding a platform to mount all your electrical systems to. You're probably adding cable tray and things like that to make sure we connect everything together, or use that as a pathway to connect everything together. These systems don't include fire systems. They don't include cooling systems. They don't include any of that stuff. They wouldn't include an access control system, for example, like an outdoor power module probably would, because they're intended to go in the building and leverage the resources that are in the building for that system. So why do folks do it? Typically for power skids, you're talking about a customer that's really deploying. It's really more around the speed and the repeatability angle of so you're building a big data center. You need to move fast. Again, I want to take the build of this out of the equation of building this large data center, and I can drop these in and make the deployment very simple. The great thing about a skid is everything internally is connected. So once it's on site and placed, the in and out connections are basically all you need to make. So that can be done in a matter of days and turn it up very quickly. To Greg's point, you have to have a plan to deploy these things. You have to have the right kind of building. So that is something that could work against it in a particular situation, but you know, that's really what the driver behind it is, being able to turn these things on fast. And this is my last slide. I just wanted to give some comments about what does it take to build one of these things. So prefabricated power modules are a little bit different than a lot of other products where, maybe you're not so concerned about where the product is built as long as it's built well. The factory itself is kind of part of the product and part of the product delivery. So we just kind of wanted to give a sense of, what if you're going to work with somebody, what do you need to look for? So just some comments. Typically in the data center industry anyway, the factory is an indoor solution. The factory is, and you can see this is a picture of one of our factories. We have several factories at Schneider that do this, but it's simply a big open space. We have some special material handling equipment that is used, things like overhead cranes, special equipment to roll things around. But really, it's about having that big space where we can do a lot of different things, be very flexible. The reality is, as much as I would like as a manufacturer for every one of these to be the same, they're not always exactly the same, so you have to have a lot of flexibility in your facility, in your layout, and just how the way you're managing it. And then the other big part is if you're looking for a manufacturer, is make sure they have proper testing equipment to do the tests so you can take advantage of that predictability gains that I mentioned earlier. Okay, so that's my section. I'm going to turn it back over to Brice, and he's going to wrap things up.
Thank you, Joe. Yeah, I wanted to sum up the benefits of having this approach. In addition to having some savings by doing standardization of the design from engineering standpoint, we have also some savings related to the design engineering itself by doing optimization of the different products using the maximum of each product, and also having a very close collaboration with you guys, customers, system integrators, and panel builders to really make the right design according to the expectation, and at the end of the day make the right choice, doing the best benefit from CapEx standpoint. I spoke about integration, very important topics for us. Just to give you an example, we have identified, for the simple example I have shared with you, 27 possible failure modes. So we are testing this type of things also in order to secure before the commissioning phase the different possibilities of failure, and also to have those scenarios documented in order to recover to a normal operation. Fast deployment, it's about paralleling tasks and having a lot of integration, which takes time, and the integration of the low voltage can take some time with the UPS and the transformer, and also managing the long lead time. So we have also the capability when scaling, to forecast the equipment in order to have the optimization of the equipment according to the lead time and the expectation you want to deliver the module. Quality is also a key point. The fact that we would like to the chance to standardize is also to standardize the documentation, is also to have the right skills with the people who are designing or people who are integrating the system. And at the end of the day, it's much more predictable costs. So the fact that we understand type of costs we are going to build, as well as managing the commissioning phase, where the fluctuation of time and cost can be very different. The chance to standardize this module is very a good opportunity to control this aspect. So thank you very much for listening to us. I think we can open to the Q&A.
Great. We've got thank you, Brice. Thank you, Joe. We've got a few questions already on the widget here. So maybe Joe, there was a question about commissioning after factory testing. Can you talk a little bit about that and some of the advantages of prefab there?
Sure. So in the context of putting the testing in the context of commissioning, typically what's done in the factory is you're doing up to about a level 3 commissioning. So basically you're commissioning the equipment, right? And we can expand that definition a little bit, because rather than saying I'm doing a commissioning on UPS, switchgear, et cetera, all the components, now I'm commissioning, I'm turning the system, all the things in the prefab module, into a component. But it's still basically akin to level 3. Obviously, when it goes to site, it'll be connected to other things like generators and to the building itself, where you're more into a level 4 mode of commissioning, where that will of course need to be done on site. So generally, that's what we advise. Some clients have different views on how aggressive they take that. Sometimes they might go into something that's more like a level 3.5. Some might be, if that makes sense, I know that's not probably a proper term, but go a little bit beyond level 3, or others may be a little more conservative and go a little bit less and do more of that on site. That's typically the dynamic that we have.
Great, thanks, Joe. So here's one we answered for one person, but maybe the broader audience might be interested as well. Is what solutions ready for market does Schneider have for fully green data centers, for instance, powered by wind and solar? Brice, you want to answer that?
Actually, we have the capability to design an off-grid system thanks to the microgrid team with a good representation in different regions of the world. We have, if we drill down into the technical aspects, we have different type of doing off-grid. Of course, depending on the side of the data center, that can be what we call the PPA type of model, where green production is done out of the site and is funded by the operator and managed with the utility to be able to secure that the amount of power is 100% or 50%, 70%, whatever, a green production of energy. The other aspect is for smaller side, where we can have independent system close to the data center. So we are much more speaking about hundreds of kilowatts rather than megawatts, of course, with this type of model. And that's a combination, as mentioned, between wind or solar type of production. And we have another system which is power generation that can be also added to that, but it's not 100% green as we speak. Did I answer the question?
Great, thanks. Yeah, that's you answered it from my perspective. We can follow up with the individual person as well. So here's one, Joe. This is gonna, I'm sure, make you cringe, but I'm asking anyway. What is the approximate time for manufacturing, say, a 2 megawatt system? How quickly can we get that? Out?
Okay, interesting question. There's a lot of ways to answer that. I'll give you one or two. So the actual integration, and when I have all the equipment in the factory, and there is some dependency on the complexity and things like that, takes about 4 or 5 weeks, I'd say, once I have all the equipment. So when we talk about overall lead time from order to delivery, the time is longer than that, and that's usually driven by the lead times of things like switchgear or the enclosure. So that can end up being something like many months because of that upstream lead time. So that's I guess, an answer. The other answer that I tend to give is, especially with clients who are building numerous data centers, is the way for us to manage this in a collaborative way is to look at forecasting where we know where something's going to happen in advance, and then we can plan to it, and it's not a reaction from an order. So that's generally, and I think that's really not just us, but I think the way the whole marketplace is starting to work towards is if we sort of plan this, then it won't be a crisis and be a reaction to a purchase order. It's more of a collaborative planning and forecasting exercise, which I know you can't always do, but that's really the way to get around that some of those lead times that we see on the equipment.
Yeah, just to add to that, I think the important thing from my perspective is that you're looking at this from sort of a entire Gantt chart of the entire project perspective. So if you just think of, let's say, if you're thinking of it in terms of just the switchgear, this is going to be longer than the lead time on the switchgear, but it's replacing a lot of the work that would generally be on site, so that we can help kind of compress the lead times from an overall perspective. The other point I wanted to bring up that Brice mentioned several times, and it sort of has been a learning for me over the last few years, is that as engineers, we tend to want to optimize the design, right? As we can always find ways to go make it incrementally better. But if we're thinking of it in terms of how do we more quickly deploy data center infrastructure, is understanding the components that are more standard, therefore shorter lead time, can help us kind of optimize the overall performance, even if we're maybe sub-optimizing certain aspects of the design. And so I think that's a trade-off that we try to work with our customers to go understand that you know, this whatever this pilot light is, or this great feature that we think we have to have, do we have to have it at the expense of 4 weeks or 6 weeks or 8 weeks of lead time? And so you know, I think that's an important aspect of it as well. All right, we've got maybe time for probably one more question, and then we will follow up on the follow up off the chat with all of the questions that came through. So so will there be any specific challenges from a maintenance point of view associated with this prefabricated or modular construction? Joe, you have a thought there?
I mean, I think yes and no. Obviously, when you deploy things, you need to think about maintenance. At least when Schneider designs and builds something, that's a key part of the design, is making sure that maintenance is taken into account. All the working clearances that are required inside of a building are also required inside of a prefabricated module. You know, we still have to build it to code and respect all those same things. So so the maintenance should be a similar exercise, but there's certainly some unique things that need to be taken into consideration in terms of how it's placed on the site and the access and things to it. But if that's all taken into account, the maintenance is not going to be any different from the standpoint of doing it in the building or in a module.
Yeah, and in fact, you know, due to the sort of standard, you know, if you're thinking of it in terms of deploying this sort of over and over and really get to a standard repeatable, I think there are some really interesting things that can be done around maintenance and sort of next gen technologies around predictive maintenance and some of those things as well. So want to make sure we point that piece out as well. So there are a few more questions on here. In the interest of time, I think we will go answer those offline. Thanks to all of you for your time and attention. We know that time is the most valuable resource that we all have these days, so very much appreciate your spending it with us. Thanks to Brice and to Joe, and look forward to being with you all again in the next quarter. We will post a recording of this, and feel free to reach out with any additional questions as they come up. So thanks to all of you, and we will be with you again soon. Thank you.